name is Andrew.
Hello, my name is Tajdeed Bari.
Hello, my name is Ransh Mishra.
My name is Abhinav.
And we are
PLS. We land on the moon with extraordinary precision, but landing is only the beginning. Once on the surface, every mission faces the same problem: moving equipment, tools, and cargo across unstable terrain where time, safety, and reliability are very important.
Mobility is the bottleneck. The surface is covered with fine regoliths, rocks, and steep slopes. Traditional wheeled rovers struggle in these conditions, and when mobility fails, the mission slows or stops entirely.
All systems are designed to travel, not to operate effectively on it. As a result, surface operations remain inefficient, risky, and heavily dependent on actual time. PostPoint addresses this directly. It's a modular robotic mobility system designed specifically for reliable movement across unpredictable lunar terrain, from flat regolith to jagged boulders.
We began by researching NASA's technical reports on lunar surface logistics, regolith terrain, and uncrewed operations, which constantly identified mobility, stability, and modular cargo handling as a critical gap in sustaining lunar missions. Based on this research, one of our main steps of our innovation is creating a prototype here, which also has extra robotic arms or drills that can be attached on pre-made holes on the top. Our main innovation for this prototype was the pivoting structure for our drivetrain, in which has also a wheeled drivetrain and a legged drivetrain. This helps us to easily move through rough terrain and smooth terrain. If there was a boulder in front of you, you can drive in front, turn into leg mode, and you can drive over the boulder. However, using these insights, we had a lot of significant drawbacks for our prototype, including structural wobble, concentrated joint wear, and reduced stability under extreme load. Using these ideas, we have created another prototype, but this time online. Using Onshape, we have created a Crayola CAD, which helps us visualize the rough shape of our new robot. This time, instead of an entire pivoting structure of our prototype, we decided to have the wheels fixed onto the main part of the robot and have the legs retract. This helps the robot retract the legs completely, and still the wheels will be contacting, which helps with ground clearances and suspension, instead of our old prototype, which can create a lot of joint wear in the legs and the wheels. Using the Crayola CAD and our knowledge using NASA's technical reports and our prototype, we developed the official PostPoint CAD using Onshape. A solution we had for a major drawback we had was that instead of having the wheel attached on the arm, we can have it attached directly to the chassis. This allows the legs to move freely without the wheels and the arm to have extensive wear, allowing further long use of PostPoint robots. This refined architecture improves reliability, lowers mechanical stress, and supports a modular payload interface that allows PostPoint robots to carry more cargo and deploy any tools needed for any research missions, and integrate future missions and specific attachment on the robot, including sensors that can be attached on the leg, and robotic arms, drills, cameras, and other instruments.
Is hybrid mobility. Each PostPoint robot uses wheels for efficient travel over unstable ground. But when the traction is lost or obstacles appear, articulated legs will deploy to step, stabilize, and climb. This allows for continuous operation across terrain that would stop conventional rovers.
Mobility is not just limited to one vehicle. Multiple PostPoint robots can operate independently or coordinate together as a team, distributing loads and adapting to terrain dynamically. This reduces the mission's risk and eliminates single points of failures.
Our go-to-market strategy focuses on institutional adoption. We target space agency and defense research grants, including NASA and international lunar programs such as the Artemis program, followed by partnerships with commercial lander providers under the CLIPS program. By positioning PostPoint as a scalable mobility infrastructure, rather than a single mission asset, we enable sustained funding, repeat deployment, and long-term growth.
PostPoint is designed for long-term development. Robotics and field are modular, repairable, and upgradable, and can be lowered to the lunar surface using trace systems on landers such as the SpaceX, Starship, human landing systems, with compatibility across future platforms.